Hi, welcome to minimum spanning tree session, which is called minimum weight spanning tree. The spanning tree is defined as the least cost subset of edges of a graph that is connecting all the nodes, which is called minimum spanning tree. Here, whenever we are having the graph, then we will start to construct the spanning tree by selecting any node in the given graph and adding it to the tree. Initially we will take a tree will have empty set. Okay, here we will select any vertex, then we will add into the tree. For example, here we have selected node number 6, we are adding into the tree. Then we will pick any least cost edge from a node in the given graph. For example, 6 we have selected. Here we are having 6 and 5, both are the edges. Here least cost edge is 5, so we will select the edge 5, which is reaching to the node number 5. So here which is not in the tree already, which is this edge between 6 and 5 is not in the tree. Again we will add that edge into the when we are adding that edge into the tree, we should check the property of the spanning tree. It should not form the cycle in the new tree, right? So we have to repeat this again by picking the least cost edge from the node 6. So there is no other edges in the 6 with the least cost. Then we can select the 5. So from the 5, you see we are having 3 edges available, the 5 to 1, 5 to 3, and 5 to 4. Among this 2 is the least cost. Then we can select the edge 2, which is least cost, to the node number 3. Then here we will add that edge into the tree, right? And when we are adding that edge into the tree, we should check it should not form the cycle. It should not form the cycle. Then we will check other vertices which is reaching from the 3. Here 4 available, and 1 and 2. Here we are having the different values here, which is the 3, here 3, here 2. So minimum cost is here. We can select the edge with 2, which is reaching 4. Then again we can check is there any minimum cost edges. So here there is the possibility of minimum cost edges from the 3 itself. We look at that, which is reaching the 2, which is reaching the 2, which is having 3. And from the 3, again we are checking least cost, which is having the edge 3, which is reaching the node 1. So this is one of the least cost spanning tree, that is minimum spanning tree. You may ask here, why don't we use this edge between 2 and 4? Yes, that is also one of the possible spanning tree. We can construct like this: 6 to 5, then which is having the edge cost 5. Then from the 5 to 3, edge cost 2. Then 3 to 4, edge cost is 2. Then we can select the edge between 4 and 2, which is the edge cost 4. Then from the 2 and 1, edge cost is here uh, 3. So calculate that edge cost: 3 plus 4, 7, 2, 9, plus 2, 11, 16. So 16 is the cost here, but here cost is 3 plus 3, 6 plus 2, 8 plus 2, 10 plus 5, 15. So edge cost is 15. So 15 is the minimum cost spanning tree. That's why we have not selected this edge between 2 and 4. Instead of that, we have selected this edge. So here whenever we are constructing the tree, we should select with minimum cost. So here the minimum cost of this nodes are here the 15. So whenever new edge we are connecting, it should not form a cycle. That is the important property of spanning tree. To break the cycle, you must remove the edge with another greatest cost edge, right? That means we have to select always the edge with minimum cost, right? Graph can have many possible spanning trees and also minimum spanning tree, right? So two spanning trees may have same cost, that is also possible, right? For example, right, suppose if I am having one or two here, three and four, right? So if I am having the different structure of this tree can have same cost, that is also possible, right? So if I'm having like this, so same structure, same graph, I mean same tree can have both may have cost 10, this is also may have cost 10. So we can select any spanning tree as a minimum spanning tree. The general algorithm is here, as initially we are taking the given tree is empty, number of edges are empty and vertices also empty. Then while a does not form a spanning tree, right, then we can do find the edge, that is safe means here safe edge in the sense when you are selecting the edge that should not form the cycle, and also it does not destroy the invariant property. Invariant property in the sense that edge when you are selecting and adding into the minimum spanning tree, it should follow the property of spanning tree, that is it should not form the cycle, and also that edge should give you the minimum cost, that should give you the minimum cost. So that edge is called safe edge. Then safe, if it is correct, then you can choose that and add this minimum cost edge, and it is not forming the cycle will be added into the given set of vertices and set of edges. Then again you have to repeat this. If there is unvisited vertices available, then you have to find the safe edge, then that safe edge will be again adding into the given list, right? So until visiting all the vertices, you have to keep on add the safe edge into the minimum spanning tree. So applications of the minimum spanning tree is to construct the electronic circuits in the printed circuit board, right? Here set of pins are electrically equivalent by wiring them together. To interconnect n number of pins, we can use n minus 1 number of wires. Here the pins are acting as a vertices, that wires are acting as a edges. So here we can use the minimum spanning tree to minimize the total length of wires and also to avoid the short circuit. When you are constructing the network also in the computer lab, then if you have 100 systems, then you can use the minimum spanning tree to connect the network, right? So we can reduce the length of the wires when we are establishing the network. Thanks for watching.